And we will continue to look at the history of lighting, which has been around now for the last few millennia of human evolution. We started out by burning fuels inside lamps. In the geometry, quite similar to that lamp we see over there. However, that has mainly been used here at KVA using incandescent lighting and electrical light. Over the last 100 years or so, since Edison invented these things, the fluorescent lamp was introduced somewhere in the early 20th century. And then we saw much later the arrival of the lighting element that we are now celebrating in this year's Nobel Prize. And what you see is, of course, an enormous increase of the power efficiency, of the use of electrical energy in generating light. Now, something like a fourth of our electricity consumption in most industrialized economies goes to illumination. So these effects, having much more light for much less electricity, is really going to have a big impact on our modern civilization. We see that impact. You see it in the streets, you see it on the cars, you see it in the lights, you see it in new optical environments like this one from a festival of lights somewhere in Japan. And they're all based on the use of these light-emitting diodes. They come in different colors, not only white, but blue, red, and green, as we saw here. And they have not only the advantage of much better using the electrical energy, they also give a very much longer lifetime, maybe 100 times longer than that of the standard incandescent lamp that is now being going into retirement. Also, it doesn't bring the mercury along that the intermediate generation of fluorescent tubes is contributing as a problem to industrial civilization. So we will most certainly be able to use this technology. But it took a long while to arrive at this possibility. The red LEDs have been around since the early 1960s. The green LEDs, some years later. Advances in semiconductor technology using band gap semiconductors with different band gaps lies at the base of this. But the blue thing, the blue light emitting diode, was very difficult to accomplish. Not that there was a lack of effort. There was continuous efforts in industries to generate blue light emitting diodes. Because today, with the advantage of having these available, we can generate all those colors. We can combine in color mixing with 3 different colors in the individual lamp. Or we can use, as you find mostly maybe on the market today, a blue or UV emitting LED illuminating a thin layer, absorbing this energy and converting it to other colors. The structure of these lamps are very similar to what you have at the base of your semiconductor electronics that's driving the information technology. A diode, a combination of semiconductor materials where you have one layer carrying holes, one layer carrying electrons. They transport these charges at 2 different energy levels, but when they meet in this intermediate layer, the active layer, they recombine, and when they fall into each other, they turn up and turn light on. That was light, that was there. So this is the physical mechanism that lies at the heart of this device. And our laureates of this year have contributed greatly by the inventions that made it possible to grow the gallium nitride and alloys of gallium nitride materials in the particular geometry suitable for building such diodes. You have to be able to grow these, and that was attempted for 3 decades before the inventions of Akasaki, Amano, and Nakamura. You have to be able to form these diodes, and there was a great problem with passivation of the dopants being used to create these. It was solved by discoveries and inventions in these Japanese labs. And you have to introduce more colors, and you have to build them into structures which well confine the electrons and the hole searching each other in order to generate light emission. And these are the structures as you find it today, a great number of abbreviations on top of each other. Each layer may be a fraction of a micrometer thin, deposited from the vapor phase in big synthesis machines. What you see at the market might be a light bulb like this, where the tiny speck of matter with this structure, sub-millimeter size, is emitting quite a bit of light. today, or yesterday, when this figure was compiled by satellite photographers of NASA, this is where we see light being generated in the industrial economies, mainly with the great urban areas of the world. But of course, the access to electricity is very weak in many areas of the globe. There is no electricity net. They don't have the electrical power generation accessible. This is changing because solar lanterns being used to little electricity help out in balancing the systems where you have solar photovoltaic plants and store them in batteries for use at night. So in the future, I believe this map will look different. And this is very much in the mind of Alfred Nobel, who wanted to give his prize to the inventions for the better benefit of mankind. And this is why we award this year's prize to Akazaki, Amano, and Nakamura.
Thank you, Professor.